Hi, my name is Zachary Bischoff. I'm a research scientist at Georgia Tech. In this talk, I will be presenting our work on characterizing internet outages and shutdowns. This is an interdisciplinary work together with all the folks listed here. In the last few years, more than 1 billion people around the globe have been impacted by internet shutdowns. And to be clear, when I say internet shutdowns here, I am referring to instances where governments intentionally completely cut off internet access across the entire country. Despite decades of research and numerous improvements to the performance and reliability of the internet's underlying infrastructure and protocols, such progress loses its impact when the internet's entire technology stack is purposefully taken away, sometimes for days at a time. Furthermore, these shutdowns often occur during tumultuous times. Shutdowns during these periods can cause a significant amount of additional stress and uncertainty in an already difficult situation. And unfortunately, recent trends suggest that it is unlikely that such practices will end anytime soon. As you can see in the graph on this slide, over the last 7 years, the overall trend has been an increasing number of shutdowns each year, with as many as 40 being reported in 2021. Our goal with this work is to shed light on the characteristics of countries that utilize internet shutdowns and how these events can be distinguished from what we refer to as spontaneous internet outages. Examples of spontaneous outages can include things like disruptions caused by power outages, cable cuts, or natural disasters. Though the community is aware of the existence of internet shutdowns, previous works on the topic typically focus on a single case study or a series of related events in a particular country. In this work, however, we present the first interdisciplinary longitudinal study of both government-ordered internet shutdowns and spontaneous outages. Our analysis in this paper focuses on national scale shutdowns and outages occurring over the period of about 3.5 years, between January 1st, 2018 and August 1st, 2021. This data set, which is one of the contributions of the work, includes 219 shutdowns across 35 countries and 714 spontaneous outages in 150 countries. Our analysis also incorporates data from a wide range of sources spanning multiple disciplines. Before I dive into the results of our analysis, I'll first briefly describe some of these datasets as well as the tools we used in our work. Much of our work relies on IOTA, the Internet Outage Detection and Analysis tool, which we use to manually identify and record internet disruptions around the globe. This has been an ongoing activity carried out by members of the IOTA team since January 1st, 2018. Just to give a brief overview of how IOTA works, visitors to the website can identify internet disruptions on IOTA by inspecting multiple signals related to internet connectivity. The set of signals includes BGP announcements, IOTA's active probing campaigns, as well as traffic data from a network telescope. This screenshot shows one example of a disruption that was visible in IOTA. This particular case represents a disruption in Sudan in late June of 2022, where we observed significant drops across multiple signals. Our analysis also leverages data from Access Now's Keep It On initiative, which we refer to as the KEO dataset. Since 2016, Access Now has continued to record internet censorship events, as well as publishing annual reports summarizing what happened over the previous year. This dataset includes multiple details on each event, such as the type of censorship techniques involved, and examples of this include whether it was a full network shutdown, whether connections were throttled, or whether certain apps or websites were blocked. It also includes links to relevant news articles and details on the types of networks affected, as well as the geographic scope of each event. We use a subset of this data as our work is focused on specifically on full network shutdowns occurring at a national scale. One of the contributions of our work is that we developed an automated process for merging the IOTA and KEO datasets. This was particularly useful for our analysis, as both of these datasets each have their own unique benefits. Specifically, IOTA's use of network telemetry data in near real time provides us with precise start and end times for each event. The IOTA dataset also includes spontaneous outages, which provides a baseline for comparison that we can leverage to better understand the distinguishing features of internet shutdowns. Though our analysis focuses on country-level events, IOTA also includes data at the subnational region and ASN level. This is something that we're exploring studying further in future work. The KEO dataset, on the other hand, allows us to identify shutdowns that are part of the same macro event. And macro event here refers to a series of shutdowns corresponding to a single real-world event, such as a series of daily curfew shutdowns in Myanmar during the 2021 coup. The KEO dataset also provides an additional external source of validation for events that have been labeled as shutdown events. As mentioned earlier, our analysis also incorporates a variety of additional datasets. This includes macroeconomic indicators like GDP and the prevalence of internet access. We also use indicators from the varieties of democracy database, including each country's liberal democracy score. We also leverage multiple datasets related to real-world events, specifically those containing information on the occurrence of coups, elections, and protests. Finally, we also incorporate a variety of networking-related datasets. This includes APNIC's eyeball dataset, as well as, for example, data on the prevalence of state ownership of networks and address space in a country. I'll now briefly describe a few of the highlights from our analysis. Please be sure to refer to the paper for a more in-depth description, as well as the rest of our results. First, we found that countries that were more autocratic tended to be more likely to have both internet shutdowns and spontaneous outages when compared to countries that experienced neither. This figure shows the distribution of liberal democracy scores for countries where shutdowns occurred, countries where spontaneous outages occurred but not shutdowns, as well as countries where neither event occurred. We see that both countries with shutdowns and countries with outages tend to lean more autocratic than countries with neither. With that said, the difference was much more obvious with countries with shutdowns. One of the most significant findings in our study was that we found internet shutdowns were much more likely to occur on days of political mobilization. Specifically, we found that days involving protests, elections, or coups, shutdowns were much more likely by about an order of magnitude, even more in some cases like with elections and coups. We also note that we did not identify any signs that spontaneous outages were notably more likely to occur on these days. This confirms previous studies that internet shutdowns are indeed highly political in nature. In our analysis, we also used our curated list of IOTA disruptions to compare and contrast the temporal aspects of internet shutdowns and spontaneous outages. We found that, in general, spontaneous outages tend to have shorter durations. We also observed that spontaneous outages showed a much smoother distribution, while shutdowns typically had a large number of events concentrated on a few specific durations, a sign of planned human actions. We observed a similar trend in the recurrence rate for each type of event. In addition to having a much shorter time between consecutive events, internet shutdowns tended to be highly concentrated on precisely 1 to 4 days after the previous event. Looking at the distribution of start times over the course of an hour for each type of event, we found yet another similar trend, with internet shutdowns being significantly more likely to start on the hour. Specifically, over 70% of shutdowns began at the top of the hour in terms of local time. In conclusion, this work provides insights on the characteristics of internet shutdowns and how they compare to spontaneous outages. This work also highlights the importance of continuing to collect additional data on internet shutdowns and conducting further analysis, as it unfortunately appears that large-scale shutdowns will continue to be enforced in many parts of the world. We are currently exploring ways to incorporate our analysis into IOTA's dashboards and are working to develop a sort of early warning indicator for internet shutdowns. If you're interested in learning more about this work, please be sure to check out our paper. Our outage dataset for this work, as well as the code we used in our analysis, are publicly available on GitHub. The full IOTA outage dataset covers nearly 5 years and is updated daily. We are also collaborating with Access Now to improve the accessibility of our datasets and to make it easier for researchers to incorporate both in their analysis. Thank you for listening.